Welcome back to Daily AI News at Let's Data Science. It's 27th August 2026. Today, we're diving into some pivotal developments from the future of machine intelligence to major product launches. Let's get to it. Our top story today: NVIDIA is putting fresh numbers behind the extraordinary scale of AI infrastructure demand. For its fiscal second quarter of 2027, NVIDIA reported $96.2 billion in revenue, up 18% sequentially and 106% from a year earlier. Data center alone generated $89 billion, growing 117% year over year. The Associated Press reported that revenue and adjusted earnings exceeded Wall Street expectations. NVIDIA reported non-GAAP diluted earnings of $2.22 per share. Looking ahead, NVIDIA forecasts fiscal third quarter revenue of $108 billion, plus or minus 2%. Importantly, that guidance assumes no data center compute revenue from China, and it remains a forecast rather than a completed result. NVIDIA also expects gross margins around 74%. On the technology side, NVIDIA says its Vera Rubin platform is now in full production. For machine learning infrastructure teams, these results are a strong signal of accelerator and data center demand, but they do not establish deployment-specific pricing, availability, delivery schedules, or capacity. Those still depend on region, hardware mix, supplier agreements, and workload requirements. From NVIDIA's sales to the customers reserving future compute, Anthropic is reportedly making a massive infrastructure commitment. Bloomberg reported that Anthropic agreed to spend $45 billion over 6 years to rent AI cloud capacity from Nscale's flagship data center development in West Virginia. TechCrunch separately reported the arrangement, but Anthropic and Nscale have not publicly confirmed the terms. According to Bloomberg, the commitment represents about 460 megawatts of power capacity and is expected to use NVIDIA Vera Rubin chips, with those chips beginning to come online in late 2027. That timing is crucial. This is capacity associated with a future data center buildout, not 460 megawatts of operational compute available to Anthropic today. The reported deal illustrates just how physical frontier AI has become. Reserving accelerators is only one piece of the equation. Facility construction, electricity delivery, networking, hardware installation, and cloud service readiness all have to align. For infrastructure planners, it means power interconnections and construction milestones can become as important as chip specifications. And because the commercial terms come from reporting based on people familiar with a private agreement, the $45 billion figure, 6-year duration, and capacity allocation should all be treated as reported rather than company confirmed. From renting compute to potentially owning a major distribution platform, NVIDIA is also at the center of an unconfirmed acquisition report. Reuters reported that NVIDIA has agreed to buy Hugging Face for $12.9 billion, citing reporting from The Information and its source with knowledge of the agreement. Neither NVIDIA nor Hugging Face had responded to Reuters outside regular business hours, and neither had published an announcement in the sources reviewed. So this should not yet be treated as a publicly confirmed or completed transaction. Hugging Face operates a widely used platform where developers and researchers share, discover, test, and deploy AI models and datasets. Earlier reporting showed that Hugging Face had been approached about a sale at a valuation of $13 billion or more. TechCrunch reported on August 24th that no deal had been reached at that stage, providing context for the negotiations, but not independent confirmation of this newer report. If completed, the reported purchase would put an important open model distribution platform under NVIDIA. But there is no announced integration plan. Developers should not infer changes to Hugging Face governance, model hosting, repositories, tooling, or access terms unless and until the companies publish details. From NVIDIA's platform footprint to the security boundary of its hardware, University of Toronto researchers have disclosed GPU Thor, a rowhammer technique targeting NVIDIA Ampere workstation GPUs with GDDR6 memory. NVIDIA's August security notice confirms demonstrated bit flips on the RTX A4000, A4500, A5000, and A6000. The researchers report denial of service and host root privilege escalation demonstrations on an ECC-enabled RTX A6000. GPU Thor uses non-uniform memory access patterns designed to evade GDDR6 target row refresh while accounting for GPU memory request coalescing. With ECC disabled, the paper reports between 72,000 and 377,000 bit flips per gigabyte across the tested cards. With ECC enabled, researchers observed 387 detected but uncorrectable double-bit errors and 2 triple-bit errors that were incorrectly repaired. Their privilege escalation demonstration corrupts GPU page tables, with the researchers saying an unprivileged CUDA program can ultimately obtain a root shell on the host CPU. NVIDIA now recommends layered defenses: sysECC together with host IOMU or DMA isolation, memory error telemetry, and careful tenancy and workload isolation controls. The finding does not establish that every NVIDIA GPU or memory architecture behaves identically, but it shows that ECC alone is not a complete rowhammer defense on the evaluated Ampere workstation cards. Beyond hardware security, NVIDIA is reportedly putting more capital across the AI supply chain. Business Insider says NVIDIA has committed $18 billion to equity investments for the rest of its fiscal year, targeting model makers, infrastructure financiers, and other private companies. Reported August activity includes a $1.5 billion investment in SB Energy, a stake in Cloverleaf Infrastructure, and a multi-billion-dollar agreement with coding startup Poolside. The strategy extends NVIDIA's exposure into power, data center development, software, and models. That infrastructure push also comes with new efficiency claims for Vera Rubin. NVIDIA says Vera Rubin NVL72 delivered up to 30 times higher throughput per megawatt than GB300 NVL72 on agentic workloads, plus up to 35 times lower token costs. The tests use semi-analysis AgentX coding agent trajectories, including long context and tool activity. These are NVIDIA measurements, however, and the early Vera Rubin results are still pending semi-analysis review and do not yet include Vera CPU performance for tool calling. From inference hardware to the models it serves, Alibaba has released Qwen 3.8 Flash Next with downloadable weights. The multimodal mixture of experts model has 125 billion total parameters, with 6 billion activated per token. Alibaba says Qwen Cloud Access is coming soon at 16 cents per million input tokens and 47 cents per million output tokens. It also claims lower training cost and stronger performance than Qwen 3.7 Plus, particularly for coding and office tasks, though the supplied reporting does not independently validate those performance claims. From model capability to agent security, GitLab has patched a high-severity Duo Claude flaw affecting Enterprise Edition. GitLab says an authenticated user with developer permissions could, under certain conditions, use user-controlled configuration processed by the Claude agent to execute arbitrary commands in a continuous integration context. Self-managed operators should upgrade to GitLab 19.3.1, 19.2.5, or 19.1.7 as applicable. GitLab.com is already patched, and GitLab dedicated customers need no action. Shifting from AI systems to the people building them, Levels.fii analysis prepared by Hakeem Shibli for Let's Data Science finds the median AI compensation premium has plateaued. At L3, machine learning and AI engineers earned about 1.34 times comparable non-AI peers in late 2024, falling to about 1.29 times by mid-2026. Meanwhile, pay concentration increased. Levels.fyi reports median engineer compensation around $635,000 at OpenAI and $665,000 at xAI, with substantial private company equity in those packages. And finally, the open-weight trend is reaching local agent workflows. Meta released Muse Glimmer, a 30 billion parameter open-weight model under the Apache 2.0 license. Meta designed Muse Glimmer for local coding, function calling, multimodal text and image input, and agent workflows, and says it can run on a Mac or PC with a single consumer GPU after quantization. The reported benchmark results are Meta's own, so teams should independently evaluate tool reliability, permissions, privacy boundaries, and performance on their target hardware. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in, stay curious, and we'll be back tomorrow with the latest in AI.